Good morning, 6-man. Can you hear me? Hello? Good morning. Testing. Okay, let's get started, please. Ladies and gentlemen, I can stop talking. Thank you. I'm Bob Hinton. Holy is remote. Didn't want the IETF meeting to interfere with his holiday, so he's home. Holy, can we hear you?
I can hear you. It's a bit noisy, but not too bad. I hope you can hear me.
They can hear you better than they can hear me.
Well, that's good. I have the override button then.
This is much better. We can just hand this off. Okay, so we're trying out the new IETF Chromebook to display the slides, and I've been instructed how to do it, so I think I can do it correctly. We'll see. So welcome to 6-man. We'll get started. Let's see. There we go. This is the note well. I'm sure you all have this memorized now. We still need a Jabber scribe. Barbara is taking minutes, so who are you? No, Mr. Ryan. Okay, thank you. So now we have a Jabber scribe. Good. All right. Repeat your name again, please.
My name is Thomas Ryan.
Thank you. So this is the agenda. We have a very full agenda today. It's basically, there's two things. Well, the introduction that I and Oli are doing now. We have 3 working group documents. We gave priority to giving each of these enough time. I think this will work, but if the working group documents discussions run over, we're going to allow that to happen, and some of the other talks, which are newer drafts that have had less discussion, we may not get to. But I think that's the right way of running the meeting. But we won't let the working group document discussions go on forever either. But so we've given most of the other drafts 9 minutes, and so they're mostly going to have an opportunity to present, give a summary, maybe ask for clarifying comments, and then bring the discussion to the list. Any updates on the agenda or comments? I assume everyone is here who's speaking. Or if you're not, tell me. Okay. So Oli will do the document status.
Yes, okay. So let's see. So we have not published any new RFCs since the last IETF meeting. We have one document in at the RFC editor. It's currently in auth 48. So there's a couple of comments that I'll do today, and that document should be published very soon. We have one document at the IESG. That's the node requirements document. That got quite a few comments from the ADs. There's one or two main issues outstanding. Tim, do you want to say something about the open issues just right now, if we got the time, please?
Yeah, 2 minutes, you and HRL. So we have one last comment that we haven't resolved, and it's around ECN. And the transport ADs and the transport review, they recommended that we make the ECN draft a must instead of a should. Now, the reminder here is basically this is just making the bits available from the IP layer up to the transport layer. So there's not a whole lot for the host to do. It's just making the ability so the transport layer can see the ECN settings in the IP layer, which is basically why they say this is not that big of a deal. But we have to run it by the working group because the original draft had it as a should. I don't know if anyone feels strongly about this being must or should. It would be great if anybody feels super strong. Otherwise, I think we're going to leave it as a should, unless that's what we passed by the working group the first time. But if people feel really strongly, the transport people feel strongly about this, but I don't know if anyone else cares.
Okay, cool. Thanks, Tim. Anyone want to comment on that, or forever hold your peace?
Okay, so I'm going to leave this as a should, and I'll push this today, and I think we'll resolve all the comments.
Cool. Thanks, Tim. Then we have a working group last call document. That's the segment routing header document. Lots of discussion on the mailing list. Lots of issues in the tracker. That's on the agenda after this talk. Next slide, please, Bob. Then for the active working group documents, we have the ICMPv6 error for discarding packets due to processing limits. That's not on the agenda. A while since that's been discussed, so we should probably get some speed on that one again. The privacy extensions, this document, that's on the agenda later today, and the v6 only flag is on the agenda as well. And I think that's all for the document status. All right, and then we have the documents of interest. There isn't really much to update here from what's been said on the mailing list. I believe it's in Suresh's hands to discuss with the IP Wave working group to see what the conclusion will be. But we'll take this back into 6-man when some of the issues that was raised here have been resolved. So see how this one goes, but we'll keep an eye on it for sure.
Good. Well, I think we're done with this, so we'll go to the next talk. Darren, do you want to come up? Not really sure how that goes back in, so we'll keep that. All right. Good morning, everyone. We have 40 minutes for this discussion on segment routing header. I'm going to go through the presentation. We're going to have maybe 10, 15 minutes or so at the end of this for discussion. If anyone wants to come up with the mic at that point, I'm sure we'll have lots of folks lining up. I'll ask folks to just save their comments till the end. Otherwise, we might consume that 40 minutes and go beyond. So this morning, we're talking about segment routing header version 14. It's been receiving a lot of comments on the list. We've had a good number of open and closed items. We're going to go through all that today. There's been a very large group of contributors and collaborators, not to mention those most recently commenting on the list and providing their feedback, providing insights, providing texts, and opening and closing issues. So thank you to the collaborators we've had in the past and the new contributors and collaborators that we've had during the last call. Your work is greatly appreciated, and we hope it continues as we close off this document. So since we're at IETF, we value running code and use consensus. This slide was presented in the last IETF meeting as well. We've added Huawei into here. Linux implements the SR header and HMAC. As of actually 4.14, I believe the 4.10 one didn't implement everything. Cisco has the SRH implemented in 2 OSs across XC and XR. FDIO VPP released in 1704, April of last year. Bell Canada Barefoot had come out with a P4 implementation in May of 2017. Huawei has 3 platforms on the go, with running code working on those 3 platforms. And Juniper has some prototype implementations as of the last IETF. We're keeping track of interoperability in Spring SRV6 Interrupt. That document has not been updated since March, but as additional interoperations get proven, we'll update that document. So whenever that doc's updated, we'll send it out to the 6-man group as well. All right, so today, what's our agenda? We'll go through a last call update. We'll go through changes from revision 10 to 14, and there's been a lot of them. Most of the document has seen significant rewrites. We'll go through the last call issues, what we've closed and what still remains open. And we'll cover our next steps and where we plan on taking this document based on the working group feedback so far and based on the open issues. So in the last call update, we had 47 issues opened during the 2-week last call, plus a few that came trickling in over the last couple of months. It's resulted in actually, I have 130 here, it's closer to 170 emails on the list. I think that's more than one per day. There's been a lot of good discussion, debate, and feedback, clarifications, example text, lots of stuff going on the list. So thanks, folks, for keeping that up. We've had 4 versions of the draft, which many people have reviewed and provided comments on. It's resulted in 34 issues closed with 13 issues remaining open. And I grouped those into a few segments at the end of the presentation, so we'll go through those. So first on revision 10 to 14. The first thing you notice when you open revision 14 is that the introduction, section 1 and 2, have gone from 4 or 5 pages down to a single page. There was a great deal of text in there that folks had commented on as contradicting itself or contradicting other sections of the draft. So we tightened that up, and we're relying now on a SR architecture specification that's received Spring Working Group approval and IESG approval, and it's waiting for an RFC ID, RFC number to be assigned to it. In the introduction, you'll notice a document map, and you might be wondering why we're showing MPLS here. There's a parallel between the SRV6 data plane as implemented by the SR header versus the MPLS data plane as implemented in MPLS. The IETF Spring segment routing architecture document is the one that defines our segment routing architecture. And that's the one that, that we're basing this work in the SR header on. And that's one that we're taking a lot of terminology for SR domain and SID and all that stuff from. The IETF Spring segment routing MPLS is the MPLS data plane implementation or architecture, I should say, of the segment routing architecture. And it obviously has a dependency on the segment routing architecture and a dependency on RFC 3032, which is the MPLS label stacking RFC. And you can see the parallel here between the MPLS and IPv6 document map. So the IPv6 data plane implemented by this draft is, of course, dependent on the segment routing architecture. The draft FIFI Spring SRV6 network programming is the SRV6 architecture draft for the SRV6 data plane implementation of segment routing architecture. Now, it is dependent on the SR header, but there's no dependency from the SR header back into draft FIFI Spring SRV6 network programming. The reference in the draft is informational only, although I know there is some discussion on the list, and we'll keep talking about that on the list at least. Maybe some folks will come up to the mic with their opinions, but we'll keep that as an open issue to discuss and see where we go. But this document map provides a general overview to readers as to how SR header fits within the larger segment routing architecture. The SR header is the next portion of the draft, and that's remained largely unchanged from version 10. It's still a routing header with 32 bits of the reserved part of the routing header containing the last entry flag and tag field. The segment list is still a set of 128-bit segment IDs, and we have optional TLD data. The flags, though, have seen some large changes. We do have a IANA registry defined for flags to be allocated within. The OAM flag, the OBIT, has moved out and been accepted by the folks authoring draft early spring SRV6 OAM. That OBIT is defined in that draft completely now, so our previous definition in the SR header didn't give quite enough conversation as to how and why this OBIT was needed. The OAM draft does. The PBIT protected bit, we're leaving to some future FR draft to define. The A bit and HMAC bit, these bits were used to alert an implementation of important stuff in TLV data. It was noted by some folks that we can use last header entry and header extension length, as well as some local policies to determine when we were going to inspect those TLVs. The A bit and H bit have therefore been removed, and we're relying on that utilization of last header, header extension length, and local policy to determine when we're going to inspect those TLVs. As far as the TLVs themselves go, we've removed the ingress, egress, and opaque TLV. I have feedback here saying that they were not needed. In fact, they were probably better described as the use cases for them were not presented in the draft. So we'll leave other drafts to define how those TLVs would be used or if they will be used. So they've been removed from the SR header. The NSH TLV has been moved out to the draft SUCLAD Spring SR service programming. They've accepted the definition of that TLV and are moving forward with that definition and the use cases around it. We've introduced another pad TLV in the draft to be a single byte pad, pad 0. And we'll probably have some more discussion as to how those padding TLVs are used. Right now, there's only a single one defined in the draft that gets used at the end of the set of TLVs, providing padding out to a 8-byte boundary. But we'll continue some discussion on list to see where that goes. There's a bit for mutability that's been defined in the TLV types, higher bit, and we've a recommendation in the draft now that all the TLVs are in fact 8-byte multiples for new TLVs that are created to avoid need of using the padding bits at all, or the padding types. After the SR header and TLV definition, we come to a section in the draft which is describes a few different node types. So we define a source node, a transit node, and a SR endpoint node, right? And the source node definition is any node that originates an IPv6 packet with a segment in the destination address of the IPv6 header. It's important to note here that it does not necessarily contain an SR header within that IPv6 packet, but a source node is just one that contains its segment within the destination address. The transit node is a node that forwards an IPv6 packet where the destination is a locally configured address or a segment. It's the same as any other transit node for IPv6 today. The SR segment endpoint node is any node that receives an IPv6 packet where the destination address of the packet is locally configured as a segment. Okay, and this is a node where all of our segment endpoint processing goes, and any SR header processing goes while the packet is in transit. Now, it's important to define the 3 node types so that we can define packet processing at those node types. And by combining the different areas of the draft where we had kind of spread out this packet processing into processing at these 3 node types, an implementer can now go through and see exactly what they need to implement at a source node versus an endpoint node. So for example, a source node's responsibility is to really steer traffic through an SR policy, where an SR policy is a set of segment IDs, and that set of segment IDs is used to build an SR header when necessary. The description within the draft has cases where it's not always necessary to build an SR header, and that's defined. Also defined as to how a reduced SR header gets created and how ECMP is handling by use of flow labels. Packet processing at SR segment endpoint node really comes down to the first two entries in these bullets. So at SR segment endpoint node, we define an example processing of a fib entry. So we look up a destination address of a packet and we find a fib. We're not specifically limiting an implementation to this particular design. Implementations may be able to come up with other designs as to how they want to process SIDS, but this gives them the logic that needs to be implemented. So when we do match a destination address to a locally instantiated SRv6 SID, we have a section clearly in the draft now that defines what the processing needs to be at that point. And when we match that destination address to a local interface not configured as an SRv6 SID, then we have a section that defines exactly what the processing is in that case. The last two entries there are primarily the transit node behaviors. Okay, for the SRv6 NSID, we pulled together several portions of the document that, where the end processing was kind of spread out over several portions, and we've combined them all into section 431 of the document. Section 431 defines just the NSID behavior. We previously defined an n.x SID behavior, which folks might recall was a segment that when present would forward a packet out a particular interface toward a particular next hop. We've removed that definition since it wasn't necessarily necessary to define the SR header. We didn't need the n.x definition as well, so we'll leave other documents to define that behavior. So we concentrate only on SR end behavior right now, and that end behavior is simply when a packet's received, we go to the next segment, look up the destination address of the next segment, and that behavior, along with the ICM PV6 error handling, is fully defined in section 431. So any future drafts that want to, or documents that want to define new SRv6 SID behaviors can use 431 as a template in their text and implement new behaviors by modifying that text within new drafts to define their SID behaviors. We also define TLV processing within that NSID as a matter of local policy. So local policy tells us when we need to look in the TLV section of the SR header, and if there's an HMAC in there, how we process that HMAC. I covered the stuff on new SID types. After the source and SR endpoint definitions in the draft, there's a set of illustrations that define and give examples of packet processing at various nodes, so at SR source node, transit node, and endpoint nodes. And we cover off two examples for intra-domain, so traffic between, for example, node 8 and 9 in this little diagram. Within the SR domain, it's traffic solely within the SR domain, and traffic that traverses the SR domain from node 1 to node 2, where node 3 and 4 are involved in inserting and removing an outer IP header and SR header. So the deployment models were updated to give a clear definition of how we treat nodes within an SR domain versus nodes without an SR domain, or outside of an SR domain. And for nodes within an SR domain, we have a greater level of trust that they are able to generate packets that contain SIDs and SRHs for segments within the domain, where we would want to permit forwarding of any traffic that contains a SID that's sourced by any node within the domain. From nodes outside the domain, we need to be less trustful of what they generate, and in general would not permit traffic destined to SIDs within the domain from entering the domain, sourced by nodes outside of the domain. However, we define a case where the SR domain may be extended to nodes outside the domain via the use of the HMAC.
Right, that covers the changes between revision 10 and revision 14. Now, let's get into some of the issues that were closed off of those 47 issues in revision 14. In the introduction, we had 10 issues related to the introduction, primarily around service-based instructions. Remove that text. Definition of what happens when interface addresses are present within a segment list. Defining how SID routing and forwarding is handled, how prefixes covering those would be advertised, why and when an SRH is processed was clarified, as well as removal of any mention of insertion of SR header insertion and defining it only as insertion at source. That's at an SR source node. On the SRH itself, 16 issues were closed, primarily around the segments left consistency with RFC 8200, the flags, and TLVs. The SRH processing, we closed off 8 issues, covering ECMP, removal of discussion on multicast and decapsulation, concentrating only on end processing and defining that more clearly, and then also defining ICMPv6 error generation during that processing. What we're left with now for open issues, those 13 open issues, we have a set of 62, 63, and 64, which I believe are closed off, and I'm working with the authors of those issues to verify that they are closed. That's going to go on over the next couple of weeks.
So,
Yeah.
I don't know if you can hear me, but I think for the open issues, it'd be good to get probably discussion with each set of issues instead of waiting till the end.
Oh, sorry, say it again.
So I think for this part of going through the open issues, it'd be good if people came up to the mic for each slide to talk about them, as opposed to doing them all at the end.
Okay. Yeah, we can do that. Okay, so on the edge filtering, we have 3 issues remaining around the ACLs, and there's discussion on the list regarding how those ACLs are created, what information they contain, what are the ACs within those ACLs, and then how do we use those to determine when to inspect that HMAC. So if anyone wants to come up and remind us about what those are, or give any further comments on them, we'll welcome that at this time. Otherwise, I think it's fairly clear as to what needs to be done on the list, and we're going to have some work that needs to be queued up on those. But Ron's coming up.
Ron Bonica, Juniper. We had a good conversation about this on the list. The work that remains to be done, we need to clarify what the ACL is, and then understanding what the HMAC covers and what it doesn't cover.
Yeah.
Figure out what attacks can sneak through.
Yeah,
that's work for this week, next week.
It is, yeah, absolutely. And yeah, we'll see that in a couple slides too. Hopefully, Ron, come up again if it's not clear at the end in the review slides. Let us know. Okay. On the tag fields, we closed off a number of issues related to tag, but I think we still have more issues that need to be closed off here, 37 and 61 in particular. And I believe the action there is for us to more fully define what that tag is and how it's processed, when it's created, why it's created, and how it's handled at an endpoint. Which is, yeah. I think we just have more work to do, more text, more definition to provide to the working group on what that is. Any comments on that, folks? Okay.
Yeah.
Oh, yeah, go ahead.
For the
Sorry, name and...
Yeah, Mohamed Wakadia Orange. Yeah, I think that's, yeah, win-win and bad. There is no specific use case that for which we are requiring to use the tag field. And I think that's the straightest way to go forward is just to define that field as unassigned bits and then move the draft as it is, because there's no, unless you come with a particular use case in which we are clear about the usage of this one, in addition to what you have already in the IPv6 packet itself to classify and to differentiate the behavior of the treatment of the packets themselves, I think it would be difficult to come up with I would say, a clear specification of what the tags will be and so on. So I would just suggest that you just make it as an assigned and move it forward.
Right. Yeah, and folks have recommended on the list too. Personally, I think it's probably worth spending some time and trying to make sure we define what those, to an acceptable degree what the tag is. I don't think it's going to take forever, but certainly if that's if what you suggest needs to be done in the end, then we can go that direction. Yep.
This is Robin from Huawei. I would like to add some information about the implementation and the interoperability test. So now, until now, there are several implementation about the SRv6 and the SRH. So now that's in fact based on, as far as I know, the interoperability test has been done through the vendors and the ESA and Spirent tester. So I think that now that the more interoperability test will be done in the coming months. So that's based on the interoperability test, we can understand more about the reasonableness of the SRH standards. It will help to refine this draft. Okay, that's all. Okay.
Yeah, so definitely more, of those implementers who are implementing. Yeah, I'll kind of repeat what Robin said. There's more interoperability testing and more documentation of that is certainly appreciated. So anyone with implementations that are interested in interoperability testing, I guess we need to make sure we might as well send those out to the list as well, or contact the individuals with implementations. Okay, after the tags, there's the TLV discussion. We have issue 38, 54, 55, 62, and 67 open for those. Primarily concerned with the padding. A new one here that I don't think is captured is insertion deletion, defining the cases where a TLV may be added by a midpoint or removed by a midpoint. That was something I mentioned on the list. Folks commented, hey, the draft doesn't talk about that. We're going to need some text around that. So I'll commit to adding that text and getting the working group to give feedback on that. Oh, thanks. All right. So I missed one here. We're now at 6. Unless that's 67. Was that 67? That's okay. Okay. Okay, so there's a new ticket open for insertion deletion if folks didn't hear that. The optional processing per local policy as well needs to be defined in the draft. We said it's optional per policy. There's an action at the end here to define what the data model is for that. And that's in our next steps. Oh, do we have any more conversation around TLVs that folks wanted to mention? Questions or concerns?
There's a good discussion going on about why TLVs are not implemented in destination options before the routing header. Oh, by the way, Ron Bonnick and Juniper. We should probably come to conclusion on that and document why we made the decision. It can go off in an appendix someplace.
Yeah, I think you're right, Ron.
Zafar from Cisco. So there are many TLVs that are not in this draft but are defined in other drafts in Spring. Those are OEM, PM related. There are at least, I think, 4 drafts that talks about use of these TLVs, and also for service programming. And there are many use cases of these TLVs. I just want to highlight that.
Okay, and I think I pointed the working group to those drafts, and as those drafts mature, I'm sure there's going to be more discussion on those within this working group and review of them. All right, so where do we go next? And how are we for time, Bob? Okay. All right, so this I think covers off what was discussed at the mic tags. We need to document usage. TLVs, we need more information on TLV processing text and usage text and clarification, as Ron had mentioned. On the HMAC, this is something I didn't talk about in the changes between 10 and 14. We as a working group and we as a group of authors have not spent a whole lot of time in that security section. The people who have noted, hey, there's some problems in there that need to be fixed. So I think the next step on the security section is that we need to do a deep review of that and probably rewrite that security section. So it's much more self-consistent, and we pull out the HMAC processing in the security considerations. We put it up with the HMAC definition so that it's fully contained within one section of the document. Folks can look at that section and understand completely what the HMAC is covering and what it is not and why. And finally, Adrian had called out a while ago, I believe revision 10 of the draft, the need for a management section, which I deleted in revision 11 saying, well, it wasn't required that we had a management section. But now with the ACL discussion and the discussion around what the HMAC, the data the HMAC actually needs, I think we do need to add that management section back into the doc, at least to define the data model for SIDS, for SRH insertion, SRH insertion at source, what data is needed in order to build that SR header, what data is needed in order to populate that SID entry in the FID, and what data is needed in order to add an HMAC TLV to an SR header. I think if we define that in the management section, there'll be a clear kind of API for other documents to then define how those, oh, that got very loud, how those data entries are, how those elements of the data model are satisfied. All right, and that concludes my portion of the presentation. I just wanted to thank all those folks who have read the multiple versions, spent the time to go through the text in great detail and provide their comments and feedback. Anything now in the question and answer portion that I can't answer, I'll make sure I go through the recording and fire off notes on the list so that we cover it.
Thank you for all your work on this, but there are a number of issues that have been raised on the list that don't seem to have been captured. I don't know why. Probably it happens, we're all human beings. I'm not going to try to recreate all of them on right now at the microphone, but one example is quite a long time ago, I raised the issue of a lack of clarity on when you encaps, when you decaps, when you are required to encapsulate, how the SRH gets stripped at the edge of the domain properly since we are required not to leak it. This is the structure of the document. It may be that all the pieces are in there somewhere, but as a reader, I can't get there. And as a very experienced reader of RFCs, if I can't get there, I think I can reasonably conclude that other readers can't either.
Okay. Yeah, and yeah, it's a great thing to note. So let's make sure that after this we revise that thread on the list and make sure that we cover that off as well. I might as well open an item for that then, Bob. Already done. Okay, that's efficiency. It's not? Oh, disappointing. Okay, any other questions or comments at the mic, folks? Do we have a considerable amount of time, I imagine? Yep.
Okay. On the previous slide. Romy from Huawei. Yeah. So I'll add one more comments about the TRV work. In fact, until now, I think that in the IETF. Okay. So now that's in the IETF, it's noticed that in the programming work in the forwarding plane has been done several of the working groups. For example, in the SFC working groups, the NSH header, there's the TLVs, and also in the LM, in the IPPM, and there's also the TLVs in the LM header. So we think that is, so now that is the programming in the forwarding plane is promising the solutions for the future. So that we would like that is for the SRH, we can, this is a good chance so that we, since we keep this possibility for the TLV, for the flexible the programming capability for the future. Yeah, in fact, and also you just mentioned by Zafa is also that in the Spring Working Group, there's the several this the use cases, and that is justify the usage of the TLVs in the SRH. Okay.
Right, and so I'll make sure I take the action then when I review the recording to make sure that that we follow up on those. Any other comments, questions, folks?
Just a procedure comment. So I think it'd be good for, since there are so many different working groups that are involved in defining TLVs and extension, it'd be good for this working group to set a base and let the other working group build on it for the use cases that the other working group has. For otherwise, it may become very difficult for 6-man to scale and for all this. There's a many multi-groups that have TLV that are.
Okay, so that is make sure that there's a full, if I just paraphrase that, make sure there's a full definition of how and when to create these TLVs, so that it's clear and there won't be misconceptions as to when they should or should not create it. I think that goes as well to what Ron had mentioned, and that we need to have that full definition of when the SRH TLV is used versus not used.
Indeed.
Is that correct? Okay.
Some sort of baseline.
Okay.
Ron Bonneke again. This is probably just as much a question for Bob and Ole. When another working group defines another bit, another TLV, of course it has to come here for ratification, no? Yes, okay, good.
And just a correction on procedure, so this working group would need to make sure they read and review that section of the relevant document and say, and provide the expert opinion. Is that correct?
Yeah, I mean, I think this will, it's not just this work, but I think that's something that needs to be coordinated. I don't think we exactly know what the right answer is. The other comment I wanted to make, I think this was in the document statuses. I mean, given the long discussion and number of changes, when we think all the open issues are done, we will do another working group last call, because I think we want the working group to read the new document, which is quite different from the one we originally did the last call on. So I think that's warranted given the time and scope of changes.
Anyone else? Once, twice. All right.
Great. So I'll switch the slides. Good.
Thanks. Do I want that? Yeah. Okay. So this is the IPv4 go away bit. We started this at IETF100. Originally, we were thinking of an April 1st RFC, to be quite honest, but it sort of mutated into something more serious. Having noticed that on the IPv6 only network there, and it's probably still true here, dual stack hosts were in fact configuring IPv4 stuff and attempting to reach IPv4 services on the link. And the proposal came out of discussing how to stop that. At least one large enterprise planning IPv6 only has already supported this proposal, so there seems to be some feeling that it might be useful. The draft was adopted as a 6-man document after the previous IETF. It worked. So what's the behavior of a dual stack host? And by the way, pretty much everything on the network these days is a dual stack host. Broadcast traffic, ops and stuff. Potentially that doubles the state in switches, which on a large wireless network can be an issue, on any large network. It drains the battery on wireless hosts, not just the ones generating this traffic, but because it's broadcast traffic, it drains battery on every machine that receives these broadcasts, whether it wants to or not. And of course, it leaves a security risk potentially because it means IPv4 is there as an attack vector, even if it's not serving any other purpose.
So the main content of the draft.
It's bit 6. We propose calling it 6 as its name. If that doesn't confuse you, go read Lewis Carroll. When it's 0, it basically says this is not an IPv6 only link, and that of course is the default state in existing code, in existing implementations. When it's set to 1, it says this is an IPv6 only link. And the draft normatively updates the flags registry to add that bit. And technically we have to say we're requesting this bit from IANA, and we're requesting them to call it bit 6, but we think that they'd probably do it. So what did we change after the working group adoption? We changed the name to be the IPv6 only flag to remove any doubt about its semantics. We changed the focus to make it clear that this is an administrative flag. It's set by a network administrator. It needs to be set in all the routers on the link. And it's telling the hosts we don't offer any IPv4 services on this link. It's IPv6 only. We added an applicability statement and a clear definition of what IPv6 only means. We added some clarifications, particularly about what happens if the lifetime of all the routers on the link expire. Basically, at that point, the flag reverts to an implied value of 0, because nobody has told you it is 1. We clarified that it only refers to versions of the Internet Protocol, so if you're running Novell or whatever, you still can. And we expanded the discussion of layer 2 filtering because it was pointed out that a lot of wanted IPv4 traffic can in fact be got rid of by filtering the IPv4 ether type in the switches. But we point out also that that doesn't get rid of all the IPv4 traffic. And so we still think there's a role for this flag, even if you're doing layer 2 filtering. I don't think we said in the draft, but my opinion is that this is a safe bit. There don't seem to be any scenarios in which it can do damage. Right. So that's basically it. We want to know if there's still open issues, because we're not aware of any. We want to know if people feel this is ready for a working group period last call. I don't know what that period's doing in there. To advance to proposed standard. And the microphone line is open.
George Michelson from APNIC. Brian, I like the idea, all right? I'm not opposed to an anti-evil bit, and I'm not trying to say it's a bad idea. But the attack vectors that come to mind when you think about evil bits and non-evil bits are the triviality of it being flipped by an intermediary and the consequence. And so I'm sitting here thinking, if we rolled back 20 years and we imagine there's the vestigial moment where NetWare, that was it. I was having to try and remember what it was called. NetWare or DECnet was implicitly live at some low-level interface binding on a host because of the legacy of what's shipped in an OS and the risk that someone on a switching fabric with no routing intent turns up services that will provide the naming binding or the file service binding or the printer binding. And because these low-level primitives are live on that OS, they magically glom onto it, and suddenly you've got this packet flows happening on your switching fabric because someone has turned on NetWare, even though you, the network administrator, had no intent of running NetWare. And we kind of worked through those risks. We didn't have to build into protocols never do NetWare bits to handle that. We just allowed them to age out. So I know it's kind of arguing in the odd sense, but why do we need an anti-evil bit? What's it doing that is subtly different that we didn't have to do to get rid of DECnet or to get rid of NetWare as persisting protocols? I don't get it.
Well, you're logically correct, but that doesn't.
Like I said, I don't want to say don't do this bad idea. I'm trying to work through the model.
Yeah, I mean, and there is a reason that we originally thought of this briefly as an April 1st RFC, but then we thought, wait a minute, there are circumstances in which you do have a slight win here. Okay.
Lindsay, I think you should clarify what it means when the lifetime is 0. Like if I have a router that's on, there's only one router on link and it says lifetime, its RA lifetime is 0 because it has no uplink. The flag is basically, I don't even know what it means. It says the flag is valid for 0 seconds. I don't know what that means.
Well, I think we could we could say it's not applicable to that scenario or something. I think you're right. Barbara, did you write that down? My co-author wrote it down.
Lee Howard, I want to respond to George. My memory of NetWare and IPX is, well, I guess as old as everyone else's. And my recollection, I seem to remember spending an awful lot of time trying to manage to get drivers installed for those protocols, and they were never installed on clients that I used by default. IPv4 is installed on practically every client I touch by default. And so this is changing default behaviors that I don't think we had when we dealt with other things. DECnet is a slightly different case. For operating systems that ran, that operating system, that was probably the default behavior. But I think we were able to change that much more manually because you had administrators involved in setting up networking protocols at the time. I think that's the fundamental difference that George is looking for.
Yeah.
Jim Linkola. Yeah, responding to George, I actually think it could prevent some attack vectors because let's say in 5 years, people might, 10 years, I don't know, it's some time, people might do not want to run before. And so people might forget to put all this DHCP snooping or whatever, this spoof prevention stuff. So this could tell how this is V6 only network, so don't even try to do V4, so there is less risk of getting some random DHCP server on your network, right? Potentially. Why?
Because random DHCP server will send you a thing saying, there is
No, but if my host...
Yeah, but Jen, I could equally be a V4 only network and someone could stand up V6 service and flash out 6 only here, guys, and turn off the DHCP behavior.
Well, in this case, you are in trouble. If you don't do array guard now, you are in deep trouble, and this is your rest of your problem.
Okay, the point is that all the routers on the link have to set this bit before you're allowed to believe it. So a rogue who doesn't set it doesn't matter. Yeah, sure.
I mean, logically, we talked about this. There's no way to make this secure. Just say it's advisory, right?
Yeah, it's not.
So you're saying like we can turn off DHCP snooping. You can never turn off DHCP snooping until the end of time, because if the rogue DHCP4 server is there and you're on a V6 only network, they send you an RA saying this network now has V4. Right?
Yeah. If you don't like broadcast networks, don't use
it sends an
broadcast
RA
networks.
with. Yes, if you have RA guard, you can't do that. Yeah.
Okay, thank you, Andrew. So we should maybe ask the other chair what to do next. Ola?
me see if I can get the mute button off. I wouldn't mind having this discussion as a part of a working group last call. And if no one objects, I can't see the microphone line, so I assume it's empty. Then
The microphone line is empty.
Yes. Yeah, so let's do that. There's clearly a few issues that needs to be thought through a little bit more, or at least get a more common agreement on. But I think we could do that as a working group last call.
Okay, so I guess the authors will collect comments for another week or two, put up another version, and then send it to the co-chair.
Thanks, Brian.
Fernando?
I believe Fernando is remote as well. At least that's what he said on Jabber.
Okay, can you hear me? Okay, that's perfect. I will be presenting the RFC 4941 bis. Yeah, next slide.
Tell me when. Tell me when you want me to advance.
So this first slide
is
tries to summarize the motivation for RFC 4941. Essentially tries to summarize the issues that we tried to address in the revision of the document. If you look at RFC 4941, it prevents the use of only temporary addresses because they are configured in addition to the addresses.
So, Fernando, I don't know if you can hear me, but your audio is breaking up very badly.
It works better here. Better now? Let's do.
Can you please try to disable video and try audio only and see if that helps?
Okay.
Thank you.
So the issues that we, that have been found in RFC 4941 since its publication is first one, it prevents the use of only temporary addresses because they are generated in addition to the stable ones. The second one is that it recommends the use of the same interface ID for multiple prefixes. So if you configure multiple addresses for multiple prefixes on the same network, you would end up using the same interface ID for them, which obviously allows correlation between the activities of what you do with each of those addresses. It also reuses or can reuse the same interface ID as you move from one network to another because the interface ID are just a function of time. It also limits the number of non-deprecated addresses to one per prefix. Temporary addresses are disabled by default, and there are other minor issues, but those are the most important ones. So next slide. So what we did in 4941, let's say from a technical point of view, beside miscellaneous edits, we replaced the algorithm for generating the interface IDs with two alternative algorithms. The first one, you just compute whenever you need to come up with an interface ID. You just produce a random number. That's what we mentioned in this slide as random interface IDs. And in the other one, essentially, we produce a random number, but we use a function similar to the one in RFC 72 with the objective, of course, that some implementations might want to reuse the code. Next slide. So I tried
yeah, we're still having trouble
to
hearing you, but
summarize
keep
here
going.
or try to put in 3 different slides some issues on which we need input from the working group. First one is what to do with the algorithms. So far we have 2 algorithms, the simple randomization one and the one that parallels or that is based on the same function as 7217. As we got feedback among other people from Lorenzo Coliti, and he suggested to improve the the algorithm that we have a la 7217, which we did. But there were other comments like what to do, recommend like the simple randomization one, just provide the 2 options and not recommend any, or maybe remove the one that employs a similar function to 17 together. That's a topic on which we need input from the working group. I don't know if you prefer that we go through the questions and get input, or we go through all of the questions. Same for me. Your questions and feedback, or all the
yes,
questions?
I think that would be good.
Okay.
I'm not sure.
Okay, perfect.
Why don't we take questions
So
now?
essentially, this one is whether to keep the 2 algorithms as options without recommending any, whether recommend one specific of the algorithms, or whether to remove the one that is similar to 7217 altogether. So that's essentially the feedback that we need from the work.
Lorenzo Cluti, I think we should remove the 7217 algorithm because if the key somehow leaks, you can predict the addresses until the end of time, which seems kind of like an on-goal or an anti-goal.
That's agreed. I must say
privacy technology.
Comments that we have received from you updated the document. So the current version says something like, whenever, for example, you reboot the system, the random key is randomized. It's not an issue anymore. But again, at this point, I don't have a strong feeling regarding whether to keep it or not. Okay, so if you have any more comments on this one, next slide, please. So another topic on which we need feedback. In the initial version of this document, we didn't spell out the requirements for temporary identifiers. So we had codified, we had spelled out the requirements in a different document. And we were referencing that document from RFC 4941. Okay? So the question now is whether incorporate the requirements, maybe in the document, maybe in an appendix, or whether to put in a separate document. So far, what I have seen on the mailing list is that all seem to agree to incorporate the requirements either in the body or in the appendix. But we need feedback on what the working group thinks about it.
Any comments?
Next slide.
Okay, no one is at the mic. Why don't we go ahead?
And the other important issue is, I think there's agreement on this, but it was raised on the mailing list. So in 4941, it essentially says that temporary should be off by default, and the revision of 4941 makes temporary addresses on by default. so far there seems to be agreement on that. There were folks that mentioned that we should probably spell out what may be the implications of that. Like some security devices might not like to know multiple addresses, but I think that based on the requirements that were on for cost, on what spell that is today. I think there's no question for temporary help. But again, we'd like to get, working.
So this, they said they fixed the mic. Is this better? I think no. It's a little better.
It sounds good. It sounds good from here.
Lorenzo, could you, what is RFC 7528? I looked at it. It seemed unrelated. Is there a typo on that slide?
Well, it is related in the sense that
RFC 7528 seems unrelated.
We should always care about privacy, like pervasive monitoring. And obviously, if you don't enable privacy by default, well, you are not doing what you can, in the sense of providing improved privacy. So that's the reason for which I'm mentioning that RFC. So essentially, we're
72. Okay, so for those following along, the correct number is 7258.
That's a typo.
Not 7528.
That's the RFC that we wanted to reference is the one that is about pervasive monitoring is an attack, essentially.
It's worth noting that 4941 non-bis says not only they're off by default, but there must be a way to disable them for the user, which is things that popular platforms don't actually implement. Like on Android and iOS, there's no way to turn those off, and I think that's as it should be, to be honest. But that's just my opinion.
But just to intercept here, from coming from someone who makes very different devices, it certainly wouldn't make sense that these were on by default on most routers, for example. So it is very device specific, I think, and that advice has to be at least given the opening for.
Wouldn't that?
For that
I'm thinking out loud.
Choice by the implementer.
But wouldn't in that case you not implement 41 anyway? So whether the on or off by default doesn't really apply to you. That's what I mean. So you wouldn't implement 4941 anyway. So you don't care about the default because you wouldn't be implementing them anyway.
I might possibly, for example, use the Linux networking stack.
So are you thinking about, let's say,
right?
kind of like an applicability statement, like this applies to nodes that are behaving as hosts, or?
Well, I'm a little concerned that we're changing this to on by default. I don't think we necessarily know that's the correct answer. But we can
thing is,
take that on the list.
if we want to help in terms of user privacy, the user is not going to turn this on by default because they don't care about they probably don't even know what an IPv6 address is. So I guess the question here is if we want the the default option to be, like, let's say, privacy sensible or not.
And for some devices, it certainly makes sense.
Exactly,
that it
and
should
how
be,
do you address
by
that?
default,
Like,
right?
I guess
But
an
not for all.
applicability statement or. So I agree with your concern. So what I'm wondering is how we codify that in the document so that it applies where it should apply and it shouldn't apply where it shouldn't.
this is very open to. Fernando, just one comment on that slide. I think the last phrase is wrong. It's not that the security device assumes that many addresses per device is an attack. It's that it assumes that many addresses or rapidly changing addresses per user is an attack. So if a user tries to authenticate themselves with a whole succession of different addresses, that's what looks like suspicious behavior. The other end doesn't know it's one device or 10 devices. He just sees
that's true. Well, there's also the issue that there can be some, devices for first hop security that might not like the fact that, the same system is using multiple addresses. But I think that in all of these cases, anyway, that behavior would be contradicting, the advisory that was provided, that was generated by basic ops on multiple addresses per hop, per host. So if those devices are, behaving like that anyway, we are in trouble already. I'm not saying we are not. I'm saying that the issue is there anyway, regardless of what we do with this.
Yeah, I think at least mentioning this in the draft is the right thing to do.
I think this is the last one, if I recall correctly. Okay, that's this is the last one. Sorry, and there was another issue that essentially what we what we say in the document to address one of the issues that I mentioned before is that essentially the interface IDs should not only change as a function of time, but also as a result of privacy sensitive events, including the case where a node like disconnects and reconnects to the network. And I think it was Brian that raised the question of what we could possibly do to prevent let's say a minor glitch in the connection to the same network from producing different interface identifiers. I'm not sure if there's much more to do, like something similar to what we did for 7217, which was to use like DNA, if I remember correctly. Like, it's kind of like, trying to find a way to detect whether you are reconnecting to the same network or not. But at the very least, we might include, I guess, some work on that.
Okay, Eric, is that the mic?
So, Eric, not Mike. So, I mean, you have some things in 7217 already that says, okay, if my MAC address changed, I should change, right? That's in the context of generating the IID, but you can use a subset of that, except the time to basically figure out, should I create a new one when I reattach? If you reattach to the same BSS, whatever, right, on Wi-Fi, and you get the same prefix, and you still have the same MAC address because it didn't change underneath you, well, then pick the same one, right? But if any of those other things changed, then you should actually regenerate the IID. So I think that spelling that out, I think it requires some care to go through the actual ordering in terms of what information do you find out when you attach to a network or reattach to a network, so that you make sure that you have all of those things available before you form your IID, right? Particularly for the link local.
Well, in that...
So, but just trying to have clear concepts here and actually
besides what I was mentioning about code reuse, from that point of view, for addressing this issue, it might make sense to keep the algorithm that we have for 7217, because the idea of whether you're attaching to the same network or not is like included in the document, because there's a parameter that is a network identifier, so which can be, for example, the SSID, but whereas
yeah, I mean, it's close, except that there's a time parameter in there, and you don't. So,
okay.
If you use it the way it's written, you would generate a new one because the time has changed, but the other ones are okay.
So I guess at the very least, we might want to look at 72, the algorithm that we have 17 to see, if we can tweak it a little bit so that, just because the time changed, if you reattach to the same network, the same IID is produced. That's kind of like what we do with that algorithm, orthogonal to the question of what we end up doing, with the algorithm itself. I guess for the next revision, we try to see if we can tweak it and address what we do, that the algorithm is removed, we can go and close it.
Okay, Fernando, I think we're done. You're breaking up a lot towards the end. Are there any more comments on this? Are you?
Perfect. Thank you.
Okay, so thank you. I think we should continue this on the list.
Oh, thank you. Lou? Okay, Ron Barnica, Juniper Networks. And I have 3 drafts to show you. In the 3 drafts, I'm going to ask for codification of 4 destination options. So they're pretty cut and dry drafts. All these presentations will be explaining why I want these 4 destination options. The first one is the VPN context information option. So, for those of you who haven't lived in the world of VPNs, a VPN allows a network provider to provide, to emulate a private network with a shared infrastructure. So let's say you have sites that are in a blue VPN and sites that are in a red VPN. Blue can talk to blue, red can talk to red, but blue can't talk to red. Over the years, the IETF, specifically the BEST working group and all its predecessors, have codified lots and lots of VPNs. L3 VPN, L2 VPN, VPLS, EVPN, pseudowires, and that's how I spent the last 20 years of my life. All of these VPNs have a few things in common. They have edge devices called CEs. They participate in the VPN. They're either in the blue VPN or the red VPN or whatever color. And they connect to a provider edge device. The provider edge device is the boundary of the provider network. The PE maintains a VRF, a virtual routing and forward instance for each VPN. And the VRF is really a VPN-specific fib. The VPNs have context information that we'll talk about in a little while, and transport tunnels. So, when an ingress PE gets a packet from a CE, the first thing it does is figure out what VRF is associated with the inbound interface. It then looks up the packet's destination and the appropriate VRF. And the lookup yields 2 things, VPN context information and the next hop. The next hop is another PE at the far end of the network that is accessed via a transport tunnel. The ingress PE then prepends the context information, the stuff that it just got from the lookup. By the way, that's the stuff that I want to encode in the new option. It prepends that, and it forwards the packet to the remote PE through a tunnel. So, what does the packet look like as it goes across the network? There's tunnel encapsulation to get you to the remote PE, context information that we'll talk about in a second, and the payload that was actually sent by the CE. So, we arrive at the egress PE. What do? We receive the packet from the PE, we remove the transport tunnel header, we remove the VPN context information, and then we do something depending on what the VPN context information said. For instance, we might forward the packet through a specific interface to the right destination. Or we might look up the packet's destination in the right VRF. But any way you look at it, it's the context information that tells the egress PE what to do with the packet. Now, right now, all these VPNs work over a plethora of tunnel types. They all started out as being things that ran over MPLS, but they can run over GRE, IPNIP, IPsec, VXLAN, and a whole bunch more that I'm not even aware of. Now, for context information, currently there is one option. We use an MPLS label. The MPLS label is 32 bits long. Of that, 20 bits is the label. It contains the context information. It's actually used. 8 bits is a TTL field because MPLS is also used for forwarding. In this case, it's not used at all. 3 bits are QoS. In this case, it's not used at all. And there's a bottom of stack indicator that is used because you might have more MPLS labels if MPLS was the tunnel type. Oh, okay. Yeah. Now, the sad part here is some devices that might otherwise be PEs cannot process MPLS labels. So we have a problem. It would be great if we had another option to encode VPN context information that was not an MPLS label. What would we like it to be? A new destination option. So we're just moving the information from an MPLS label that came right after the transport IPv6 header to something that's inside the transport IPv6 header. What does this new option look like? Well, it has an option type to be determined by IANA. The ACT bits are 10, which means if the destination receives this and it doesn't understand the option, drop the packet and send a parameter problem. The change bits are 0, which means please do not change this in transit. And the option data length is variable. Right now, context information is 20 bits. We might make it 24 and pad it with 3. Or if one day in the future you need more or less, it's variable. So what are the next steps? First, we'll be presenting this in BEST, the working group that does all the VPN stuff, on Friday. Second, we're asking for adoption of this as a working group item. And then it's first, questions.
Yeah, Darren Dukes from Cisco. Since this is a TLV, basically you're taking the MPLS label value and sticking it into a TLV. How, as someone who's implementing data planes, how would your data plane then, are you going to have to walk that TLV? Are you going to say, well, this thing's always the first entry in the TLV? There could be other stuff within
No
the
rules.
TLV.
It could be anywheres. It could be anywheres in the destination option.
Right. Okay. So the egress PE then is going to have to walk through a set of
As it has to walk
entries
it today.
and find the one that it's looking for.
Yeah, it has to walk it today anyway. So.
Okay. Yeah, most of those PEs probably don't look at destination options today. That's probably the primary difference. Is that correct?
I believe that it's a requirement of an IPv6 node to walk the TLVs just in case you get an option where the option type is 10 or 11. You have to know enough to drop the packet.
All right, thanks.
Borag Ranox, how do you refer to VNI in that context from VXLAN, for example?
I'm sorry, could you repeat that?
How do you refer to VNI field in VXLAN, for example? Doesn't it give you the context that you're looking for?
I'm sorry, the DNI field? And
VNI.
Oh, VNI and EVPN?
Who are you? Borag Rafni from Ranox.
Okay. It's likely in EVPN you wouldn't use this because it's going to be in the VNI.
So but you did mention VXLAN, right? So what other protocols are you referring to?
Oh, you would definitely use it in L3 VPN, L2 VPN, maybe VPLS. You'd be using it to replace MPLS. So whenever you would use an MPLS label, you would use this if you can't handle MPLS.
This is Zafar Ali. So we have sets in SRv6 that are in destination header and give the context for the VPN. So this problem has been solved with implementations already in place for the using SRv6.
A couple of comments here. First, it's solved only in a document that has not yet been accepted as a working group document. And then it's in the Spring Working Group, neither in BEST nor here. Second, you might need to solve the problem in a network where you don't have SRv6. This works when you're running SRv6. It also works when you're not running SRv6.
If you want to address it for the work that is not SRv6, then you need to call it out that this is for the cases where there is no SRv6. Otherwise, I mean, I object to this adoption because there is a bigger discussion needed.
Okay, I think that's a debate for the West.
Hi, I'm Mark Townsley from Cisco. Could you go to slide 8, please?
Sure. Yes.
So my first comment I want to make here is the historical accuracy of what you're saying here. Context information is always encoded in UPS label stack. I thought your description of how we do VPNs with the context sandwiched between the encapsulation and transport, is accurate. That context is transmitted in many ways with many IETF protocols. L2TP back in the early days, V2 did it with a combination of session and tunnel ID, and then later with V3 with just the session ID. VNI was brought up. GRE does it with a key sometimes. There's every VPN has some sort of way. It could even be configured in the source dest of the IP address pair, so that always is wrong.
Absolutely right. The always is incorrect. What I need to do is replace that with, for these protocols, L3 VPN, L2 VPN, blah, 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 it's always done.
No,
but not
because L2TP v3 is an L3 VPN protocol. We use a session ID. So
okay, not L3 VPN, but RFC 4364.
Perhaps.
Yeah,
You
definitely
narrow it down
RFC.
to a single RFC.
Well, no,
which changes the context.
We
of
have it
the
in a few of them.
presentation. So it's just the delivery of that. I wanted to clarify, ask you to clarify.
Okay, fair
and
enough.
then this just becomes, oh boy, yet another way to do VPNs in another way, in another way, in another way. And I think we should be very careful before we add.
Could I
any
make
more
the same
to
comment about putting it in a SID?
That's one way. This is one way. So basically, it becomes: should we do SRv6 or should we do that?
Okay, if you say so. Look, that's an interesting discussion for the list. Should it be coupled to SRv6 or should it be independent? In case you don't want to run SRv6 and you need to solve this
So
problem.
all the independent is how we end up with so many different in the first place. But let's take it to the list.
Yeah.
Okay, we are over time, but let's do this. And
Just one comment. Satoru Matsushima from SoftBank. Just one comment. I'm not clear whether we need to define or keep the independent VPN ID space. I second the Mark Townsley comment, and because in the IPv6 protocol stack sense, I don't understand why we need to keep the VPN ID space even in the IPv6 ID space. I add the protocol stack.
Okay, I'm afraid I'm not understanding the question.
Why we need to keep the VPN ID in addition to IPv6 ID in the sense of the IPv6 protocol stack? That's my comment.
Well, we have information that's encoded today in the MPLS label.
Yeah,
we
but
have to put it somewhere as if we can't.
This is the part of the IPv6 protocol stack. Why do we need to keep that VPN ID in addition to IPv6 ID?
Okay, as opposed to putting it in some shim header that's not MPLS?
Yes, it's IPv6.
Okay, fair enough. Okay.
Okay. I think we'll have to stop. So I think it's a little too soon to do an adoption call. I think there needs to be, from the questions, there needs to be more, I think, justification of the motivation and more agreement on that.
Okay,
before
fair
we
enough.
proceed. So.
Okay.
next.
Okay, here we're talking about two new destination options called the truncation eligible and packet truncated option. And let's talk about why we need them. First slide. Oh, I have the clicker. Okay, IPv6 allows fragmentation at the source node only. So a source node has two things that it can do. One is refrain from ever sending a packet bigger than 1280, which incidentally is what we do these days on the internet for the most part. And the other is to maintain a running estimate of the PMTU and refrain from sending packets greater than that estimate. And right now we have two tools to maintain that running estimate, PMTUD and PLPMTUD. Now, let's talk about how PMTUD works. The source node produces a PMTU estimate. That MTU estimate's generally the MTU of the first hop. And that MTU may be larger than the actual PMTU. There may be a smaller MTU downstream. The source sends packets, never larger than the PMTU estimate, but possibly larger than the actual PMTU. When a packet's larger than the actual PMTU, an intermediate node can't forward it, so it discards the packet, sends an ICMP PTB back to the source, and the source updates its PMTU estimate. We rinse and wash again. Now, let's talk about how PMTUD breaks. Well, when the network can't deliver the ICMP PTB message from the intermediate node to the source doesn't update its PMTU, and you get persistent black holes. Now, when does this happen? All the time. For the most part, the commercial routers you buy at your favorite appliance store, they do a security model. So they would accept an ICMP PTB message from the destination. They won't accept one from an intermediate node. So PMTUD in the actual internet is fairly broken. So we need some new procedures. And now we're going to talk about the new procedures. An upper layer protocol is going to send a packet. So he marks that packet as being truncation eligible. When an intermediate node can't forward a truncation eligible packet because of an MTU issue, it truncates the packet, it marks it as being truncated, and it forwards the packet to its destination. When the destination node receives the truncated packet, he sends the very same ICMP PTB message back to the source. The ICMP PTB message has an MTU that indicates the length of the truncated packet. So you now know what the destination now knows what the PMTU is from the source to it. So we have two new options. One is the truncation eligible option that indicates a packet is eligible for truncation. The other is the truncated packet option that indicates a packet has been truncated and is eligible for further truncation. The truncation eligible packet, what does it look like? The value, TBD by Anna, the ACT bits are 0, 0. It means that if the destination doesn't understand this, that's okay, just jump over it. The option data length is 0, so the change bits are really pretty irrelevant because there's no option data to change. IANA can assign that however they like. The truncated packet option, value TBD IANA, its ACT bits are 1, 0. That means if the destination receives a truncated packet and doesn't understand this, it drops the packet and sends an ICMP parameter problem back to the source. And again, the change bits are irrelevant because the option length is 0. So what are the procedures we have? The source node sends a packet with the truncation eligible set. The intermediate node attempts to forward a packet, and it has first, let's say it attempts to forward a packet and it doesn't have an MTU issue. I'm sorry. If it doesn't have an MTU issue, it just forwards it because it doesn't look at the destination options at all. If it does have an MTU issue, and it recognizes either the truncation eligible or packet truncated, it truncates the packet, updates the payload length, overwrites the truncation eligible with a packet truncated, which means it just overwrites the option type. It doesn't overwrite the length or anything else. And then it forwards the packet. And if the packet's not eligible for truncation, it just discards the packet and sends an ICMP PTB back. It's the legacy behavior. The destination node, when it receives a packet with the truncation eligible, it just skips over it. It doesn't make a difference. And it does this whether or not it recognizes it. Yes, the packet was truncation eligible, but it wasn't truncated. However, if the destination node receives a packet, a truncated packet, and it recognizes it, it sends an ICMP PTB to the source. The MTU field reflects the packet length. And by default, it discards the packet. However, a upper layer protocol can register for delivery of truncated packets. It might want to do that because it might want to know the metadata. It might want to know how long the packet is. So that way it can negotiate things like MSS at the upper layer. And if the destination receives the packet and it doesn't understand the packet truncated, drops the packet, sends a parameter problem. So what are the benefits of truncation here? Well, it allows us to use larger PMTUs, larger MTUs. Right now, PMTD isn't working real well, and we need some tool to help it. Joel.
Joel Yeagley. Well, as you know, PMTUD is a cause célèbre for me, so obviously I'm interested in any draft that involves it in any fashion. But so the packet that you receive that's truncated is not going to have a valid TCP or UDP header, right? Because because it's now truncated.
It always is. There's a rule that says when you're truncating, if truncating causes you to cut off any of the IPv6 extension header chain or the first transport header, you may not truncate it. You just have to drop it and send to PTB.
Yeah, but above and beyond that, like the length and the checksum in the TCP packet will fail.
Absolutely.
Because yeah. So it's also necessary that the stack actually not just discard it at that point, because that would be a packet that would get thrown out under ordinary circumstances, like immediately after receipt, because like it's scrambled.
Yeah, by default, the stack would throw it out unless the upper layer at the destination registers for delivery of it, and it knows that it can do something intelligent with it.
Yeah, I mean, it definitely requires a stack change just to get to that point, right?
Yes.
Yeah.
Hey, Richard from Sky. This still relies on ICMP PTB getting back to the source?
I'm sorry, could you say that again?
This still relies on the ICMP P2B message getting back to the original source?
Yes, but the odds of it getting back to the source from the destination are better than the odds of it getting...
Yeah.
Right. Comments on this slide. It also helps you with funnel. When you empty, you change more than once in the path.
Yes, because a truncated packet can be truncated again.
Yes, and I think you didn't mention on your slide about the reasons for ICMP not being delivered, that intermediate routers just couldn't generate enough ICMPs because there are hardware limits. I'm not generating more than so many packets per second, but the destination node might, as a result, generate ICMP.
Yes, in the draft there are a bunch of reasons why ICMP might not make it from the intermediate node, but is more likely to make it from the destination. Lorenzo.
No, he's in the queue. Well, you do have a mic. We have one remote, but we're also over time.
Howard, if I understand correctly, the time a source node would send this option is if it has reason to believe that it won't accept ICMP6 PTB messages from intermediate nodes, either because of its own security policy or intermediate security policy. That seems a little unlikely to me that it would have that much information. And I think the point about the fact that your checksum won't match, if you say, hey, but upper layer protocols might want to see that packet anyway because of metadata, that sounds like an opportunity for me to throw packets with mismatching checksums at you and see what makes it up the stack.
Well, it's the same attack that you have today of forging ICMP PTB messages.
Yeah, it's just that the ICMP PDB message, like the only thing I'm going to be really looking in that one for is actually the header, so that I can figure out which flow it was associated with.
Yeah, Ron, so if I understand correctly, the reason for which the problem that you're trying to solve is that essentially ParentUD doesn't work because you don't get the ICMP error messages. Is that correct? Okay, well, a problem related with the solution is that in practice, destination options
and
don't
you're
get
more
through
likely
either.
to get them if they come from the ultimate destination.
So you're trying Okay. That's what I try to raise, because you're trying to replace something that doesn't go through, but destination options
which
don't
is the
get
next
through
graph.
either. Okay, fair enough.
Clearly, it's a problem that needs to be fixed, but that's an issue for the next draft. Lorenzo.
Yeah, similar comment. Just quickly, I think really before proceeding with something like this, you need to figure out, is there enough incentive for the source node to ever use this? And it's not clear to me at all that there is, because it might be, if there's no benefit to the source node of being able to use this, then they're not going to use it.
Yes.
They have to have a direct benefit to themselves. And second, if this doesn't get us close enough to 100%, it'll fail anyway, right? So basically, because this is going to fail some percentage of the time. If that percentage is high enough, then there's going to be no benefit, and we'll have yet another technology that doesn't work enough of the time for us to bother with it.
Okay, good point about the benefit to the source node. I'm making this same presentation in TSVWG, and I think their approval should be a hoop that I need to hop over before I can expect anybody to take it seriously.
So let's bring this to the list and do your next one, but
okay,
try to go quicker.
Okay, go quick. Unrecognized option. This answers Fernando's question. An awful lot of networks filter packets with destination options. What's more, they tend to filter the ICMP parameter problem message, which the last two drafts relied on being delivered. So, what would be a good thing to do to figure out if you're in a situation where either of those aren't going to make it? Well, what you could do is probe the network. Send a packet with an unrecognized option whose first two bits are 1, 0, and wait to see if you get a parameter problem message. If you do, then the network does everything you need. If you don't get that parameter message, either the probe or the response, the ICMP response was dropped. So, okay, let's say I want to write some software that does this. Well, I have to pick an option that is undefined and use that to probe the network. Well, which option ID should I use? I need one that's not defined today, it's not defined tomorrow, and it will never be defined. Well, the only way to do that is to define one and make sure that I never implement it, which is what I'm asking for. I'm asking to define an option. The ACT bits are 1-0, the change bit is 0, the length is variable, the option data has to be 0. The behavior when recognized is to send an ICMP parameter message. The behavior when unrecognized is exactly the same. The good news is you've already implemented this. It's unrecognized. The bad news is we need to go to IANA and ask for it. The results are good enough. You will get some false positives due to ECMP. You'll also get some false negatives due to ICMP and due to transient packet loss. But this is accurate enough for most implementations. Given that you don't have some kind of crazy configuration in ECMP paths, it should work. The use case I'll skip over because we're out of time. And again, asking for adoption, but since the other two are waiting for adoption and this is to solve, yes?
I would make one quick observation, which is that if you use the same flow label, someone who's doing layer 3 only hashing will actually hash it on the same path that the original flow actually had.
Oh, so we could get rid of the...
yeah, so, I mean, there's obviously a weird protocol change there because you're just reusing the flow label for another packet that you're sending, right? So that, but if you are actually doing a layer 3 only hash, all the information, you can replicate all the information that the actual flow is using, which is one of the reasons why BTB fails repeatedly, is because it doesn't hash on the same path.
Gillingo, quick question. So you need to somehow record the information that to this destination you can send packets with destination option, right? Are you suggesting to keep it in somewhere in the destination cache, like an MTU, and verify it periodically? Because it might be that right now you can do that, and then the path changed, and you cannot do it anymore.
That's true. That's why I say it's only good enough for working government work. A transient path change can also send you from a path that used to work to one that doesn't anymore. And that's it.
Okay.
We're back here.
Good. Thank you. Yes, that was good. That's okay.
This is a very brief draft. It was more controversial than I'd expected in a way, but I'm sure that we'll find out in the discussions. So the intent of this draft is to solve a very, very small issue. So we have, in 4862, we have a restriction on low valid lifetimes. They are not accepted by hosts in order to avoid a DOS attack vector. Okay, and that DOS attack vector is that a malicious host on the link, a malicious node rather, could send an RA with a 0 or close to 0 valid lifetime and cause all the other hosts on the link to lose their v6 addresses and be unable to talk to anyone off link. Okay, so there's an explicit proviso in 4862 to reject these root advertisements unless the RA is authenticated. Okay. Now, there are a lot of links where this DOS vector doesn't exist. IPsec tunnels, PPP links where there is no there's no possibility for another node to be on the same link. Cell networks where there's only one router. Okay, so what we're trying to do is just lift this restriction on those types of links where it's by definition safe. Note that it's also by definition safe on a network that has RA guard, but that's slightly different because the host doesn't know if RA guard is on or not. So why do we need to do anything at all? Well, there are cases where this would actually be useful to send an RA with a low lifetime. For example, if we have a multi-home network that has an outage on one upstream and you don't know that that's going to come back. Now you can also just mark those addresses as deprecated, or you can do nothing. And I know Ule is lining up at the mic right now to say that you should do nothing because Happy Eyeballs will take care of the problem. But on the other view of that is if you know that the addresses aren't coming back and you want to inform the application, then it's actually useful for the application to know. For example, on Android, when an IP address goes away, we just close all the TCP connections, return an error to the application so that it doesn't just spin there on read. And we feel that that's useful. So if you have a way to signal this, then it's useful. Another case is the new mobility modes defined by 5G networks, where you can have these shorter-lived IP addresses that they're not backhauled to a central mobility anchor, or they're backhauled to a mobility anchor that's very distributed geographically, so that when you move around, you get these IP addresses that are close to you, they have lower latency, and they're less expensive for the network to maintain. So that's another use case. So really what we're trying to say is in these cases, just allow these, when the node knows that it's one of the networks where this is the case, that it's safe to accept these arrays, just accept them. So really, also there's a proviso there, if you do have, don't delete your only global address on this network, or don't delete your only address of same scope on this network, because maybe that's, I don't know, we could delete that if the working group feels that should be deleted. This is the current text of the proposal. I'm sure we can wordsmith it. There have been a couple of, like I said, there's been some discussion on the list. One criticism was that this is a layering relation, that the host, like Slack, should be implemented at layer 4 on top of ICMP. We don't agree with that. I mean, if you have to write a Slack implementation, you've got to know a lot of stuff about the link. You need to know if it's multicast capable. You need to know the MAC address. You need to know the link type. 4862 explicitly says that you need to know the link type because there might be some default parameters that are different based on link type. So there's precedent for that. What about peer-to-peer links over, so point-to-point links over non-point-to-point networks like a V6 and V4 tunnel? We declare that to be out of scope because there's no guarantee, and the host knows that there's no guarantee that there can be no malicious node on the link.
why not make this a negotiated flag in Slack? Well, first of all, you have a downgrade attack, which is basically, we're saying this is an evil bit kind of thing, where if somebody wants to send you a rogue RA, they can just set the flag first, saying, oh, this is a peer-to-peer link, this is a point-to-point link, so here's your RA that says with a lifetime of 0, and basically you'd be subject to the same attack on a broadcast link, which is exactly what we're trying to avoid. And we should. There was more clarifications necessary, saying, okay, well, let's say that for convenience, let's say that you can't use this option on Ethernet, which of course we can't, and that RA guard is not sufficient. So we're going to add these to the text of the draft. And I think with that, I don't know what to do next. I'm here. You can throw fruit at me. Happy to take questions. And I don't know if we want to do an adoption call or see what the degree of opposition or controversy that this is causing, and take it from there.
Other comments?
Hi, this is Danny Moses. So, Lorenzo, as we discussed in the morning,
more into the mic.
I'll go. Better. Okay, so as we discussed in the morning, one of the restrictions that you have in the draft is a peer-to-peer connection, meaning one mobile host and one router, and that's too strict for 5G. It's good for 4G, but not for 5G, because 5G introduces multi-homing and make-before break handovers. So we need to find some solution for that.
Is it actually one link with 2 routers, or is it actually an interface with 2 links?
No, there are several configurations. One could be, and that would be good for us, that there is a gateway router that connects the mobile host to the 2 different routers. And in that case, that does work. But there's also a configuration where you don't want the gateway router, but you want to connect the mobile host from the same radio to 2 routers. And in that case, this doesn't work.
Okay, let's take that offline.
Okay.
Richard Patterson from Sky. So we can already withdraw default routes and routes with route information. Would this not just be a source address selection problem in like a multi-home environment if we've removed the route already?
Is your point that there's already a DOS vector where no, in a broadcast link, sending an array with a lifetime of 0 doesn't preclude the node from sending packets, because there could be another router on link, right? So as for source address selection, I think again, if you delete all the addresses, then you have no addresses to select. And so the DOS vector, on a broadcast link, it does exist, right? So we can't just write that off. We can't just delete that text. I mean, we could delete that text if we were to agree that we don't support networks that don't run RA guard, then we could delete that text. And in fact, I think, when IPv4 goes away, then yeah, RA guard is pretty much presumed to be there by definition. Otherwise, things are broken, and so we don't need to worry about it. But I don't know that there's enough consensus to say, well, we have to run RA guard anyway, and so we'll just delete this security text. I don't know. I'd be happy with that, but.
Jelenko, I think I can comment. I don't think it's about default address selection, because default address selection applies for new connections, and this you can control with deprecating by setting preferred lifetime. It looks like what Lorenzo is trying to do is to signal for existing connections. Just stop using it. You cannot use that address anymore. So preferred lifetime router withdraw rule 5.5, it wouldn't apply here.
Yeah, that's the main use case. Also, if an address is configured and application calls bind on it, that's not a source address selection problem, right?
Okay, good. I think it's too soon to do an adoption call, and you said you have some issues to work out, but keep going. Thank you. Mike, and we need the clicker back? It's right here. Oh, sorry.
Just hold it. So this is Fred Templin from Boeing, and I want to present a unified stateful stateless auto configuration service for IPv6. So a stateless auto configuration service, we know that IPv6 neighbor discovery supports stateless address auto configuration, and DHCPv6 is a separate stateful service. So the goal is to have a unified stateless stateful auto configuration service that provides the best aspects of both. So the benefits of a unified service would be that it would condense multiple messages exchanges into a single and concise message exchange, would reduce congestion on low-end links such as 6LoWPAN, satellite communications, aeronautical wireless links, etc. Reduces the number of multicast messages that can unnecessarily wake up sleeping nodes, and it accommodates both stateless and stateful services in a way that combines the best aspects of both. So one possibility is to define a new IPv6 neighbor discovery option code known as the DHCPv6 option. The option encapsulates a DHCPv6 client-server messages. So when a node comes onto a link, it can send a router solicitation with an embedded DHCPv6 option. So then routers on the link will receive the option and forward it to the DHCPv6 server. The DHCPv6 server then processes the option as a DHCPv6 client request and forwards the DHCPv6 reply to the client via the router. And then routers finally include the DHCPv6 reply in an option in their unicast router advertisements. So the benefits of this is that we've now reduced 4 more messages into just 2. There's no longer any need for examining the RA M&O bits, and legacy routers that do not recognize the option simply ignore it. And the end result is you get a single unified service for all auto configuration purposes. Another proposal for this is to use other types of stateful options such as the PIOX option, which has been proposed in a different draft. And this would be including a prefix information option with the X bit set saying that this prefix is being delegated for your exclusive use. Stateful services could also be provided at layer 2, but that would entail additional messaging on the links, where the IPv6 neighbor discovery messaging could provide a unified service. Draft history, the first version of the draft was posted back in November 2017. Several comments were received. Several other draft versions came from comments that were received. Now at draft 05, and there we have the URL for the draft. And I don't have a bullet point for it here, but I would like to ask for working group adoption for this draft. Questions and comments?
Does this work? Sort of works? It does work. Okay. Eric Klein. So I think at my very first IETF in December 2007 in Vancouver, Suresh presented a draft in DHC that included all the ND options and a draft in 6-man that included all the DHCP options. Both were, well, they kind of went down in flames. But and the second point was what I really wanted to send with the PIOX bit was essentially very similar to the signal being sent by the zero lifetime RA situation, and that is you have exclusive use of this link. There's nobody else there. It's just you. It's just you and the router, or you and the routers, right? One client node and then the infrastructure. The PIO was probably the wrong place to put that information because it raised other questions about there can be multiple PIOs and some with the X bit and some without the X bit, and then it started this whole other discussion. So my intention with the PIOX bit was to make something usable when to give a useful indication to the client that it was the only one there. In the same way that we know in quotation marks on the 3GPP architecture that when we get a /64 from the mobile network, it is in fact ours and not anybody else's, and so we can do 64 share and that kind of thing. I haven't formed an opinion for or against anything specifically just yet, though.
Thank you.
Lorenzo Colletti, I don't actually think this is very useful, particularly because it doesn't actually reduce traffic except in the initial exchange. Because if you, every time, it says every time you get a reconfigure, you have to process it. Every time you have to, DHP is a polling protocol, right? And this doesn't get rid of polling. But RA is a push protocol, so this doesn't get rid of push. So you basically, from a power perspective and from a traffic perspective, you don't actually save much. You only save the initial exchange. RAs still have to be pushed to you, and you still have to like supplicate the DHP server every whatever along your leases.
This is a case where the node is asking for an RA by sending an RS, and the router is responding by sending unicast RA. So it's not the thing where you would get unsolicited RAs on this type of a.
If you don't get unsolicited RAs, you fall off the network.
Not necessarily. If you're pulling for them all the time, we've got examples of protocols that do that.
Yes, but RS is not one of them. We tried to get consensus on saying that there was a draft that said that hosts may send RS when they think that something might be about to expire, and there was heavy opposition that got, we didn't even try.
We have published drafts that have RS-R exchanges where the RS is constantly pulling for RAs, and there are no unsolicited RAs.
Okay, so like I said, from a power perspective, that's bad.
Not necessarily. If you've got long lifetimes, it's not bad.
Common sense. It's basically worst of both worlds. You have to do both. You have to do both the polling and the push model. On standard links, you have to, like, there's really no polling for RSs.
Well, there are link types that do RS-RA with no unsolicited RAs.
Okay, but then you could do this on those link types. I assume that here you want something general in all link types. What I'm saying is that on most link types, it's not going to save power or traffic.
I would disagree with that. On an Ethernet link, for example, if you had your routers running this way, then you would be saving power and traffic.
No, because you only save power and traffic on the initial exchange. You don't save any power after that.
You don't have to have additional extraneous messages, though, after the initial exchange.
There may be a disconnect here. Like, you have to continue to poll for DHCP6, and you have to continue to receive multicast RA.
You don't necessarily have to receive multicast RAs if the routers are obeying this. So a router that doesn't understand this option will ignore it and will send back a multicast RA. And that's how the node can know that it's not participating in the protocol.
Forget about the initial exchange, okay? Let's wait, 10 minutes, okay? What happens then? How do I get a new router, default router?
If your lifetimes in your stateful and stateless information comes back is sufficiently long, you're not going to be sending a poll until you get close to the expirations of lifetimes.
So the maximum for the default router is 65,000 seconds, okay? So that does pass. When 65,000 seconds pass, how do I get a new default router?
You send a new RS and you get back another IA.
Okay, so we tried that and we didn't get consensus, but we can try it again, is what you're saying. We tried again. So what you're saying, though, is that we're turning RAs into a pull protocol where the host has to continue to send RSs at a time of its choosing.
Which can be set by the router by sending lifetimes that the host should honor.
Okay, so then we need to be very clear that then we're turning RS-RA into a pull protocol.
On the links that adhere to this, yes.
Okay.
So
yeah,
we're about out of time, but I think I don't feel comfortable doing an adoption call. I see the conflict I see with this draft is the beginning. You talk about unifying DHCP and neighbor discovery, sort of broad goal, but then you also talk about some very specific use cases, and I can't really figure out which you're trying to do here or both. And trying to do a unification, I think, is a broader issue. So I think this it perhaps needs more work. Okay. Thank you.
Thanks, Bob. So I'm going to talk about the SRv6 O&M draft. This work is going on in a Spring Working Group that would like 6Men to review. And I'm doing it on behalf of my co-authors that are listed here. Next slide, please. Oh, sorry. Okay. Okay, so what I want you guys to remember that, I mean, in this, there's some illustrations. So anything with green color is a classic IPv6 node, and anything with blue color is SRv6 capable node. Anything, any node that has an arrow on top of it is the node that we are focusing on at the given time. Now, let me talk about a bit of history of this draft. So this draft was first submitted in July of 2017, and this was submitted to 6-man working group. At that time, that scope of the draft is how do we basically take the classic ping and trace route mechanism that exists in IPv6 network and make it work for within the SRv6 network. And it got revision back in October 2017. But in February or close to December of 2018, we added also SRv6 ping and trace route, which is a ping and trace route to a SID function. And this is when it becomes more of a subject expert being in a Spring Working Group. So we moved the draft to Spring Working Group. There we added the SRv6 ping and trace route mechanism, which included a segment by segment and overlay, segment by segment ping and overlay trace. I presented this in IETF101 in London. And since then, Spring Working Group also went through a recharting activity, and this became a charter item there. There was a revision done in July, which is of interest to this working group the most. And that is as part of the last call comments on SRH draft, the OBIT was moved from the SRH draft to this draft, the definition of OBIT. And comment there was that the bit should be defined where we do define the processing of that bit. And then this draft start to also define the processing of the OBIT. So that was the reason for the move. And then we also took the O&M SID from the network programming draft into this draft. So it has sort of two sections or two major item. One is talks about the building blocks. And when we talk about the building blocks for this is we define the O&M SID. So this draft defines two O&M SIDs. One is called n.op, which is O&M endpoint with punt behavior. And then next one is n.otp, which is O&M endpoint with punt with timestamp and punt behavior. And like I mentioned, that this also takes OBIT definition from the SRH draft and adds it to this draft, which is it keeps the same location that has been there in SRH draft for a long time. And it then defined the OBIT O-flag processing as something like timestamp a copy of the packet and forward, or forward and timestamp copy of the packet, which is depending on if you want to do a line of sight blocking or not, unblocking. And then the second part of this talks about use cases. And in the use cases, it has extension like how classic node behave in in SRv6 there's a network, and then classic ping and classic traceroute, which is ping and traceroute to a loopback address or IPv6 address. And then there basically IPv6 related processing remains unchanged overall in this document. It works seamlessly with the classic IPv6 nodes. But for the SRv6 ping mechanism, we define a new message type for the ICMP. So this is something of the interest for this working group. There are INN registry requests done, so definitely like this working group to take a look at that.
So just a clarifying question, what do you mean by classic ping and tracer? I mean,
You mean something that is going to a ping or traceroute that is going to an IPv6 address and not to an SRv6
you mean like a standardized? Yeah, classic implies a bunch of other things.
Yeah, and it's standardized. I think it's a better word. I agree. Thanks. So just for the illustration, I don't have all the illustrations that are there, but just for the illustration so that we can see that this works seamlessly. Here in this example, like we have node number 1 that does want to ping an IPv6 address P4 on node number 4, which is green, which could be a classic node itself. And if the sender wants that ping to go via SID list or via certain node, you want to verify that connectivity or SID list, then it can just put in an SRH. The sender can insert an SRH in the packet as shown here and send it out. Now, in this case, the orange node or link are the SID in this example, but it can go through an arbitrary list. And if you have classic or actually standard IPv6 only node that doesn't understand SRv6, then it will go transparently through them. There will be no change. And same thing for the destination node. If the destination node, which is in this case shown as IPv6 only node, which is not capable of processing SRH, the processing does not change. They don't have to. So this is same as like for routing extension header, for any other routing extension. So the same thing applies with traceroute, that that the traceroute can actually go through an arbitrarily SID list in the network without having to change any processing at the transit node or at the destination node. It's only the ingress node that needs to put that SRH. And ingress node in this case is SRv6 capable. So then it talks about ping to a SID function, the graph, and we have two flavor end-to-end ping, where you get the destination from the egress SID, or segment by segment ping, where you can get responses from each segment along this ping. And then you have traceroute, which is hop by hop traceroute, where you get information about all the message from all IPv6 capable node as well. And then you have overlay traceroute, where you only get responses from the segments that are part of the segment list in SRH and no other node in the network. It also talks about applicability of, there was a work done for SRMPLS, and that was for a controller to be sitting and creating connectivity checks in the network. So it is equally applicable to SRv6, so it is the graph this talk about. And then it also talks about applicability of EST-ONM as well. So for illustration, I'll just go over quickly on ping to a SID function case. And in this case, it requires the egress node, packet to be pointed at the egress node. And that is done through insertion of an ONM SID in the packet by the node that is initiating it. And that would force the packet to be punted at the egress, and the egress will process the packet and send the response. Now this is where a new error code is written so that if egress doesn't have the SID that is target SID, then it can basically send a message the target SID is not implemented at egress. And in terms of the overlay traceroute, so the difference between like a hop-by-hop traceroute and overlay traceroute would be something like hop-by-hop traceroute will go TTL incrementally, and then all the nodes, in this case, the little like the green node and the blue node will respond. But in the overlay traceroute, we use OBIT, and OBIT is punt and forward behavior. So you get only responses from the node that are part of the segment, that are segmented. Same thing applies for segment by segment ping, where you get responses only from nodes that are part of the segment, that are segment node in the SRH, not any other node. So that would be include like any classic node and also any blue node that are shown in the little circle, because they are not part of segment. The processing of the OBIT only happens at the node which is part of the segment. So the process of OBIT happens while processing the segment. So author would like to get feedback from this group, and another thing is with respect to discussion of this with the Spring Working Group Chair. I'm presenting this draft as well in the Spring Working Group Chair, and then I think there will be coordination that we needed.
Yes, I agree. We're going to talk to the spring chairs and probably some ADs, and yeah, we'll figure out where this goes. At this point, I think it would be too soon to talk about adoption. We need to finish the work on the SRH draft first, I think, and then, but there'll be discussions in the meantime.
Yeah, I think they won't agree because we're working on this for almost a year now. And if we go with that logic, then everything will get blocked. But I think if it's not the last call, but if at least the adoption part can happen.
Okay, well, we need to see more discussion of this on the list as well. So, thank you.
Hi, I'm Luchi Fame from Portland State, working with Danny Moses on this. We come from the DMM, Distributed Mobility Management Working Group. Pardon me? Okay, closer. So we're from the DMM Working Group, the Distributed Mobility Management, and this is also some work going on in 3GPP. One of the things we need to do is be able to specify session continuity type in an RA, and this would be attached to an IP prefix. In DMM, there are these 4 session types that are provided, and 3GPP has these things called SSC modes, which are also very closely aligned to them. There's an ongoing liaison statement from 3GPP and IETF regarding this. And so we had a presentation and discussion over in DMM, and one of the things they requested us to do was to come over and talk to 6MAN and get your feedback. I posted a message on this IPv6 mailing list, and if you have any interest in this, we are requesting that you please provide feedback on the mailing list. We don't want to misinterpret no comments incorrectly. And basically what we're doing here is proposing an IP prefix specification option. So what this will do is basically if there are IP
some specification outside that you would like to do, that we kind of containerize this in a specification option. And in the discussions we had, we felt this is kind of the cleanest approach, and it aligns fairly well with what they're trying to do over in 3GPP. So this was meant to be a 1-minute presentation, hence one slide.
Well, you got.
I have time now, but
so.
yes, so we're pleased, we're asking for your feedback if you have any.
Eric Green, Cisco. One slide is a bit small to understand what you are doing, obviously, but we are, with a group of people, we have something called provisioning domain, which is another array options. Are you aware of this?
Yes.
Is there any overlap or?
Yeah, so we actually read the PVD draft, and one of the things that we're having issues with is, so the PVD requires you to do the extra step.
Not always.
Not always.
It's optional.
Okay, so we were, I guess our understanding of that was if you had something special you need to do, you would get the PVD, you have to go to the PVD server to get the thing.
Like
and then-
June,
yeah.
These two things are in the same PVD.
Hmm?
These two things are in the same PVD.
Mike?
So the big difference is this, what we use in the JSON file, it's in the array itself. That's it? You already no. Oh, we can talk later.
The prefixes are in the same PVD, basically same network. They just have slightly different properties.
Right.
Any
Hi, Mark Townsend from Cisco. Did you review the whole history of MIF?
No, we did not.
Well, that's evident. Towards the end of MIF, the multi-interfaces working group, we were discussing PVDs and such, and actually I made a very impassioned argument by around tying all the metadata information that you wanted to on a per prefix, and was basically knocked down, and it was, and thus was, it stepped out of the way, and then it was the PVD ID that is the collection point for that, with the optimization that Eric mentioned. So all that history is there. Please go back and review it, and don't, kind of get out of the circular loop here. If you don't mind. Thanks. So I want to respond to that. Initially, 3GPP has required this for release 15, 5G, hoping that IETF will complete this work for the release 15 schedule, which is overdue. This work started about a year ago. Now, as a response to the liaison sent from 3GPP, IETF provided various work, including PVDs, as a possible solution for this problem. They were evaluated by 3GPP, and they replied with another liaison statement indicating that they want the RA option. So, and by the way, to be honest, we think this is the most optimized way of doing that. So yes, we are aware of various other work that has been done in the past in IETF. You don't want to, 3GPP doesn't want to start be involved in some kind of a protocol just to get information that can be provided with a simple array. So this is what they're asking for. It's
It can't be provided unless these people agree with it. If there are enough of them, then it can't be provided.
okay. So in the past, okay, that's fair. In the past, 3GPP tried to use IETF technology for various things, and when IETF didn't provide solutions that 3GPP thought were good, they developed their own protocols. So I suspect that what will happen in this case is probably, if we don't provide this option, they will develop their own protocol. And that's a shame, because we could do something very simple that could help them, and they could use that. In this session today, I think there were about 3 different new options proposed for IPv6. This is yet another one. It's also a very simple one. let's not try and make something complicated from something that is really very simple. This is at least our request.
Lorenzo Colletti, I think I might have a better justification for not using PVDs for this, and I believe that the justification for not using PVDs is that these are actually in the same PVD for all intents and purposes. These addresses are really on the same network, same BCP38 policy, same everything. This is literally only about topology. This IP address is closer to this anchor point, and its lifetime is different from this other IP address. Really, this is why I stood up a little bit earlier and said we should just do this with lifetimes. But really, these two are in the same PVD, right? So in any sense that the PVD architecture says a consistent set of configuration information, these are in the same PVD.
Pierre, I think one of the things that this work talks about is the incentive to use one prefix over the other, given that they have different properties, like different delays. Because if you have an anchor, you have a longer delay to reach the server. And so I wonder, does that mean that those are the same PVDs if the prefixes have different properties? They kind of are different, so I wonder if that doesn't fit in the definition of different provisioning domains.
I mean, if they're different PVDs, it means that they're not on the same network, right? No? But no, those are actually different things that can't talk to each other. That's basically the walled garden case, right? The Deutsche Telekom case for PVDs is the walled garden case where you've got the phone service. But like the phone IP address can't talk to the internet, though.
Recall the 7556 definition of PVD.
Yep.
Consistent set of configuration information for using the network.
He's right. That is the current definition of PVDs, no matter what, like the current draft says. That's a good point. Like the standard definition of PVDs, the law of the land is right. So.
So as we know each other, we can discuss this offline, obviously. No. But consistent set, I mean, means that you can use any addresses, any prefix from the PVD to get exactly the same result. If in this case, in PVD, you get different prefixes with different result, then it's not a consistent set of information. I need to read your draft because I don't know the problem statement. Yes.
Okay, well, thank you. A couple of comments. I mean, my personal view is I think this might be useful, but I think the draft needs work in a few areas. It's not clear to me who it applies to. But what I really, I mean, this is Monday morning at the IETF, so I would really encourage you to try to get people here who are here and talk to them about this and see if we can work out some of these issues. And that goes probably with everything else we've discussed here as well. Please use for the authors or presenters, please use the time this week to try to resolve open issues, and hopefully by the end of the week you can be ready to publish a new draft that closes them all and we can move forward on some of this stuff. So good. So thank you all. We finished 30 seconds early. Very good, and we'll see you all in Bangkok. Thank you.
And don't forget the blue sheets.
Yeah, and where are the blue sheets? Thank you, I have them.